Mason.
The other side.
When you tossed a coin 4 times.
Oh, I got 2 heads.
2 out of 4, which is what?
50%.
Thank you, sir. And then when you did the 6 more to get it out of 10, how many heads total?
I got 5 out of the 6, or 7 total.
Which would be 70%.
Yes.
Who did you combine with?
I haven't combined yet. Somebody combined with me.
Clara?
I'm not finished.
You're not finished? Aster?
I finished it, yeah.
Alright, Aster, how many heads did you get out of 10?
I got 4.
4. And Mason got 7. So what is their fraction?
11 out of 10.
11 out of 20.
20.
You use the actual fraction rules. I you. So they got 11 out of 20. Mason, if you were to keep tossing coins for a large number of trials, what's the proportion of heads we would expect?
About 50-50.
Why?
Because it's a 50% chance to get one or the other.
Because we have 2 options.
Yeah.
50% because there are only 2 options.
Well, heads have a little bit more material, so you're more likely to get tails, but...
What? I'm getting it.
2 options.
I'm sorry,
I can
it's just
fit that.
objectively true.
Well, I'm more likely to heads.
Way to break his logic, Davis. Alright, so we are going to talk about the definition of probability, some myths about probability, and then we're going to look at probability models. And I have not talked this much in the last 9 days, so now my voice is like dying on me. occurs approaches a single value. The definition of probability, I tried to make it bold, but it doesn't totally stand out. Probability of any outcome of a chance process is a number between 0 and 1. And that number describes the proportion of times the outcome would occur in a very long series of repetitions. Outcomes that never ever occur have a probability of, if it's never going to occur, 0. If it's always going to occur, but we don't use 100, 1. 1 is like 100%, right? Because to change a percent to a decimal, you divide by 100. So if it's 100%, divide by 100, you get 100. The other thing, we're going to talk about probability models later in the notes. For a probability model to be legitimate, all your probabilities should add to 1.
Like, you're fine, get up.
Oh.
What just happened? Oh, we're behind. We're behind with
My whole bunch got in the way. In the box below, I have 3 example type questions similar to what you'd see in your homework. May I move it up?
Of course.
Alright, so according to the Book of Odds, the probability that a randomly selected U.S. adult usually eats breakfast is 0.61. Part A, explain what a probability of 0.61 means in this setting. So anytime you're asked to explain probability, you go back to the definition. The definition is that probability describes the proportion of times the outcome would occur in a very long series of repetitions. You can also say long run, because that's less words. And you guys know I'm all about less words. So if we were to look at a, I'm just going to use it. I didn't space these well, sorry. Let's go with a color that'll stand out. In a long series of repetitions,
Didn't you just say we can use that?
I did, but then my grammar would not be good, and I tried to do good with grammar. But I am going to abbreviate repetitions as reps. So in a long series of repetitions, we would expect the proportion, which I'm also going to abbreviate, of U.S. adults who eat breakfast
How is her handwriting so small?
what?
This is like 2 centimeters straight. What am I supposed to do with it?
Yeah, like Clara said, write smaller. But I also said I apologize, I didn't space this well. So I do apologize, Mason. Maybe if you'd been listening.
Well, that's a really hard thing for you.
And that is a really hard thing for you. Am I busy? Just a little. I am teaching a class. Okay. Huh. All right. So notice how I just took the definition of probability and put it into the context of the problem. That's all you have to do when you're asked to explain probability. Part B says, why doesn't this probability say that if 100 U.S. adults are chosen at random, exactly 61 of them eat breakfast? Definition of probability is the proportion of times the outcome would occur in a long series of repetitions. I don't know what the U.S. population is, but I know it's in the 100 millions, right?
Yes.
Hundreds of millions. So is looking at 100 U.S. adults really that many to look at compared to the population? No. So this would be considered a short series of repetitions, and therefore we can't predict what's going to happen when we look at a short series.
So if I have work for you, then you can't even put it in the grade book right now?
Nope.
Or,
Why?
They dropped him from this class, even though he...
Drop the class.
Why?
I changed my mind. I mean, they just dropped me in. I didn't even turn the drop.
So do you not have a?
So did you want to drop them or like psych?
So do you not have a?
I convinced him.
No, right now.
Well, me and Bianca.
Bianca called me.
Bianca did say some not nice words.
She's not. I think Bianca's usually nice. Well,
But it's okay.
it's okay. Just stick it out.
Any questions before we look at another example problem? No. All right, so top right, probability is a measure of how likely an outcome is to occur. You're going to match one of the listed probabilities with the statements. There are 6 probabilities listed. There are 4 statements. So you may not use each probability listed. I want you to try this on your own or talk with the people at your table, discuss what you think. 6 probabilities, 4 statements.
Are we matching them?
Match a number with the statement.
I think you work less candles as first. I just want to be less candles. Is this like a real
What?
So close. All right. Who do I want to pick on? Clara. A.
I thought that was 0.
It is 0. Thank you,
Oh my
ma'am.
gosh.
I know it was close. Allie
It was
B.
like in the goal.
1. Thank you. C. Colton.
C with 0.01.
Thank you, sir. 0.01. And D. Ty.
0.99.
0.99. Anybody have something different for D?
I had 0.6.
Either of those would work because both of those occur more often than not.
Yeah, but I feel like if it's 0.99, it should be more like, this will happen most of the time.
Yeah, but it still also happens more often than not.
It's technically a billion.
All right. Law of averages, real or not? Law of averages.
Real.
What do you think, Miss Whittle?
I think baseball players believe in the law of averages. It's not a real thing, but they all argue. They all argue that the law of averages is a real thing.
Arguing,
It's
I
not.
was just guessing.
Why is
To
it
be
not?
honest,
What it,
half the
wait,
time I'm wrong.
explain what it is before.
You know when? Okay, so
Like if I'm batting,
If you're
350
batting-
and Trey's batting 300, then I bet better than Trey.
well, duh, but that's just your own Trey. No, if you're batting 350,
Yeah.
okay, and your first 2 times up at bat, you didn't get a hit.
Then my odds of getting the third time are much higher.
This is targeted towards
That's what the law of averages would say,
True.
but it's not true. It's not true.
Yeah, you do.
You do.
No, you don't. See, that's where baseball players always argue. It's not true.
It's mental. You have to mentally trick yourself.
No. No.
I'm not gonna bitch out and go over.
Yeah, come on, man. If you go over, your dad is so mad.
I'm trying to get laid and I'm trying not to let my dad yell at me. I'm trying to get that next fucking at bat.
All right. So, law of averages, not real.
because I took it as like, you're right.
Mason, a few years ago, an advice columnist published a letter from a distraught mother of 8 children. It seems that she and her husband had planned to limit their family to 4 children. When all 4 were girls, they tried again and again and again. After 7 straight girls, that should say even her doctor assured her that the law of averages is in their favor 100 to 1. So, is it true that in the long run, the probability of having a boy is 0.5, that the woman and her husband are more likely to have a boy for their 8th child?
No.
No. Why not?
Well, if it's like,
Because it's
you know,
still a 50-50
It's still
chance.
50.
Still a 50-50 chance.
But when you take the odds out of all of them,
No.
So, you're a
Wait, okay, so-
350 batter.
No.
batter up.
Still have the same chance of getting a hit.
Still have that 350 chance.
Even if you struck out the first 2 times. Still the same chance. What?
When we say you do, like in baseball, it's not like. It's like.
Oh gosh.
listen,
No,
when we say
no,
do, it's like
no.
someone's lining out to like the center fielder every time or something.
All
They
right.
just can't find a gap.
Can I
And
flip?
they're due. They're
Can I flip?
Okay, we're talking about baseball and the law of averages. Baseball and 86 cents.
Okay, baseball is
Baseball players always argue this.
Is
You guys are going to try these 3 problems on your own / with the people at your table.
Shaq.
didn't hit it.
Can't touch it.
He didn't touch it.
I told you he didn't touch it. Just barely, like maybe
If that-
touched
if
it.
Towards like
His, yeah. It should not
wife
count
is
towards him.
That is so stupid.
Yeah.
I'd probably kill him if I was the guy.
If they win off that goal, I think the other guy will be happy. He knows he really scored it. Who cares? I wouldn't care if I got the credit. I'd just be happy if we won. Answer the 3 questions.
Answer the game.
But you know Ronaldo's gonna be like, no, that was my goal. Back.
Well, yeah, but that's
You need to answer.
Like,
You think you would know how to do that, right?
Hot streak.
I think you'll think it's hot. Oh, goodness.
I actually didn't.
Sorry, Ashley.
Right?
Wait, who's?
Yeah, I think so. I think it's explained it.
Yeah.
50%.
Because at first I did the first one.
A few years ago, I did
It's funny. Maybe it was fun.
One in three are serious, not.
Yeah, I made up. I was like, Campbell said it's
Miss Rule.
Yes.
Is this one of the...
Miss Wilcox.
All right, let's see. Who have I not called on? Trey,
Yes.
Mason. All right, Shaquille O'Neal is a 50% free throw shooter. 1 week he shot 50 free throws. In one of the games he made 6 in a row. Hot streak or purely by chance?
Purely by chance.
Purely by chance. By the way, purely by chance is going to become a really common phrase, and you guys know me, I'm lazy, so PBC, purely by chance.
EBC.
All right, let's see, who else haven't I picked on? Davis, which one's more likely? Heads, tails, heads, tails, tails, heads, or tails, 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 heads, heads, heads? The first one?
Wrong, Davis.
They're both equally as likely. They both have 3 tails, they both have 3 heads, so order doesn't matter. Equally as likely. And let's see, who else? Somebody else I haven't picked on. Amber, true or false? Mr. Wilcox's brother-in-law has 3 girls. Next baby is more likely to be a boy because of the law of averages. False. Thank you, ma'am.
But Mr. Wilcox, like, on...
Why do we call it the law of averages? It's just not a law.
Because baseball announcers, they literally spew this as if it's true. It's a myth. It's a full-on myth.
Not baseball.
All right. Now we're going to switch gears, look at probability models. Again, I tried to make these words bold, but they don't stand out as much as I thought they would. A sample space. We use the letter S when we're defining a sample space, and really all we're doing is making a list of all the possible outcomes. And we use, oh man, they told me in 3rd period, curvy braces. You'll see. When we write our sample space, I call them those squiggly parentheses, and they actually Googled it, and they're called curvy braces.
No, they're called brackets.
Yeah, aren't they called brackets?
No, we Googled
brackets
it.
are the
The brackets are the like square
Both
ones.
can be called brackets.
No,
No.
they're no,
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 different things.
no.
Oh,
Sorry, curvy braces.
Thank you. All right, so we're going to list the sample space for flipping a coin. When you flip a coin, what are the outcomes? Heads or tails? So capital S means we're looking at the sample space. You put in equal signs, so we're saying the sample space is curvy braces. We can get heads or tails.
There's just no reason for that.
That's how you do it. It's just, I don't know. They don't use parentheses. They don't use the square brackets. They use the curvy braces. Yes, it is. I just make them bad. There's an actual key on the keyboard for them. I just make them bad.
calculated stats on these like sheets.
statement.
So when
That's how they teach the equation.
AP statistics,
Yeah, that.
you can't use Google Sheets on the AP exam, so
We
you
broke
draw a
this equation at
calculator. Last year, the regular statistics class that Colton was in, I taught it all on Google Sheets. Yes, because there's no AP exam, and I didn't want to require kids to buy a $120 calculator when
That was
they
terrible. That was terrible.
So I taught them. Some things are easier on sheets. Some things are
Shoot
not
it!
easier.
Shoot!
Shoot.
Shoot!
He doesn't make
Oh
it.
my god.
All right,
Shoot again. You shoot.
we're gonna roll 2 dice and record the sum.
Addition?
Sum means addition.
That's a corner.
If I roll a 1 and a 1, which are the 2 smallest numbers, and I add them together, 2. So the smallest sum is a 2. If I roll a 6 and a 6, 12. And then I could get all the numbers in between 2 and 12, right? So 2, 3, 4, all the way to 12.
Are there certain numbers that are
Like imagine someone just
Um,
yelling at you.
For your notes, yes. If it was a test, no.
Wait, so it doesn't matter on a test, but it does matter on notes?
No, I said it the other way, Mason. Your notes are for you. If you want to put the ... put the ... On a test, don't give me a ...
No, I mean like, on 2 dice, does the actual probability of each value matter?
We're not doing that right now. Right now, we're practicing writing a sample space.
Possible penalty for Portugal. Being reviewed right now.
All right.
Did you see this? See that handball?
This time, we're going to roll a die, and we're going to flip a coin.
You had nutmeg.
Yeah, but he touched the handball.
Yeah, he touched it with his hand when he fell.
Yeah.
Oh.
He can.
Let's see. No. It's
Well, I'm ahead of you.
Does it say?
It's a handball.
Yeah, they called it a handball. Roll a die, flip a coin. So when we roll a die, we can get the numbers 1 through 6. When we flip a coin, we can get heads or tails. So if we wanted to make a sample space, put them together. Thank you. You're noticing it too, right? The lights keep changing. I don't know if it's the sky or if it's the lights, but it keeps getting darker. No, I have a ghost that messes with the lights.
Sure. That's what they say.
You saw it last year. Don't act that way.
It's just the light. It's the skylight.
Bozo.
I think it's so funny. I love watching this. Because they're so intense.
So, since die was listed first, I put all the numbers 1 through 6, followed by an H for heads. Now I'm going to do the same for tails. 1 tails, 2 tails, all the way through 6, followed by a T for tails.
No, but seriously. Here's a score in there. You can just do it.
Now this time, we're going to write out the sample space for rolling 2 dice. We're not going to add the numbers together. We're just going to put the 2 numbers. So it's going to look kind of weird. Like if I roll a 1 and a 1, when I put them next to each other, it's going to look like an 11. We just have to know that it's the 2 dice. This is going to have a lot more listed out, so I'm going to put my S, and I'm going to make my curvy brace much bigger.
Whoa, dude, chill.
Dude, we're not.
It wasn't even Cristiano.
I know, I was just gonna say.
It wasn't even
Guys,
Cristiano.
we and Davis need to watch this real quick.
Go.
A 1 and a 1.
No, I think he misses.
No, he doesn't.
No, he misses.
It wasn't even
Two.
close. The goalie
I'm
sucks.
so nervous.
A 1 and a 3.
The goalie sucks.
A 1 and a 4. A 1 and a 5. a 1 and a 6.
Oh, wow.
Then I can
That
do
was so
the
boring.
same with a 2 for the first number. 2 and a 1, 2 and a 2, 2 and a 3. I'm not gonna say all of these. Hopefully you see the pattern by now.
This is super readable and easy to understand.
Is the amount of outcomes for, like, if you roll a dice, say it has 6 sides,
Mm-hmm.
and you have what am I trying to say? You have 2 dice. Is it
Uh-huh.
like 6 to the second power, and then that's how many
Hold it.
outcomes you
How
have?
much did
Yeah.
Did you bet on this game, actually?
Yeah, me and my dad just have like $10 on each other.
It was $10.
$10 is a lot.
You chose Uruguay?
No, I chose Bush.
Oh, okay.
You chose Uruguay?
My dad chose
Try to the people who bet on
for the stupidest reason.
What was his reason?
Just the fact that you chose him.
Oh. See, Colton, I'm just bad at making the braces.
Yeah, that's not
That one looks fine, that
It's okay,
one's
I
all
can't
messed
make
up.
it.
So they look like squiggles, but they are a real thing.
I got you.
No way.
Because I can't think of anything in gambling ever with better odds than 50-50.
So, Caleb brought up a good point. He said the number of outcomes. I have 6 outcomes for 1 die, and I'm rolling 2 die. So there would be 36 outcomes, which if you were to count that, you would get 36. We are going to use that on the next page. So you might just want to write down there are 36 outcomes, because we will use that idea on the next page. Everybody okay if I flip?
A-okay.
Thank you.
2-0. That's embarrassing.
So that means Uruguay's out?
How do you lose 2-0?
Because they tied Korea, and Korea lost to Ghana, and Ghana lost to Portugal.
Ghana's actually
Ghana did good. All right. Here's another bold word that didn't show up too bold. An event is an outcome or set of outcomes an event must be a subset of the entire sample space. So the first example is we're going to toss a coin 3 times. We're going to list the outcomes in event A, which is getting exactly 1 tail. So first of all, let's start with our sample space. What are all the possible outcomes for tossing a coin 3 times?
36 outcomes.
There are not 36 outcomes. We're tossing a coin 3
Oh,
times.
never mind.
This one will have the 36 outcomes. Yeah, so if I toss, what?
6 outcomes.
3 outcomes?
Let's list them. Heads, 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 right?
Oh.
Heads, heads, heads.
It's 8.
Why is there 8?
Well, it's 3 to the second power.
2 to the 3rd power.
Whatever.
Hey,
Same thing.
It was the right track, Caleb.
There are 2 options. We're doing it 3 times. 2 to the 3rd is 8. So we could get 3 heads. We could get 2 heads followed by a tail. We could get heads, tails, heads. Or we could get a tail followed by 2 heads. Then we could do the same thing with the tail. I could get 3 tails in a row. I could get 2 tails followed by a head.
Bro.
Or tails, heads, tails. Or heads, tails, tails. So like Caleb said, there are 8 possible outcomes.
Go crazy.
Now, we're interested in event A. event A is getting exactly one tail. So out of those 8, how many have exactly one tail? And what are they?
7? Not 1?
What are the outcomes that have one tail?
Just 1?
What are they?
Oh, it is
Yes, I know there are 3 of them. What are the...
Heads, tails, heads, tails, tails, heads.
Tails, heads.
I was like stressing
Yeah.
I don't know, like.
There are 3 ways I could get tails exactly once. So I gave my sample space. I gave the outcomes for event A. Now I could use this information to find the probability of event A. Capital P means probability. The letter inside, Mason, capital P means probability. Then the letter inside is the event that I'm interested in finding the probability of. So if I want to find the probability of event A, there are 3 ways to get A out of 8 total outcomes. So the probability of event A is 3 out of 8, or 0.375. Now, this time, we're going to use the previous page because we're looking at a die being tossed 2 times, and we are interested in the sum. Event A is going to be the sum of a 7. So we listed the 36 possible outcomes. Yeah. We listed the 36 possible outcomes for rolling a die twice. Out of all of those, how many ways can we get a 7, and what are they? What are they?
1 and 6, 2 and 5, 3 and 4, 4 and 3, and then you just kind of repeat and backwards and flip it. So it's 6 and 1, 5 and 2.
You can get a 1 and a 6, a 2 and a 5, a 3 and a 4, 4, 3, 5, 2, 6, 1.
Yeah.
What?
So there are 6 ways to get a 7.
6 out of 3, 6.
Because we are looking at the sum.
So if you, that's why the house always picks that.
So if we wanted to find the probability of event A, we know there are 6 ways, and that there were 36 total outcomes. 6 out of 36 simplifies to 1/6, or if you prefer decimals, 0.1666, repeating forever. By the way, sometimes instead of saying probability of A, they will actually put the words in there and say the probability sum of 7.
So why do you use A?
They use A to make it less words. Mathematicians are lazy, but they will sometimes use the words. So I just want you to know it's not always going to be just a letter. Sometimes they'll put the actual event in words. All right. right.
Really?
When's the next game?
Tomorrow.
Did Mexico win their game?
Yeah, Mexico won.
Mexico won.
Yeah.
Why is it 4?
It's like the.
It's like the Olympics.
Yeah.
They're just trying to be like the Olympics, but they're not.
They're just trying to be like that.
But they're not.
No.
All right.
Oh, whoa.
Quiet down, please. I handed out this piece of paper. We have a lot of rules in probability. So I made copies of this to hopefully help you keep them straight. Okay. We're going to learn our first rule in a minute. And then it's going to seem weird, but the first rule we learn is the simplest rule. So down at the bottom, we're going to put it in the small little space. And I'll fill in the first one with you so you can see how I was thinking it might help you out. But then that's the only one I'm going to do with you. You will want to bring this because we do learn about one rule a day, and then you can add to it. In years past, I've let some classes use them, some classes I haven't on the test. I haven't decided this year if I'm going to let you use them or not. Everybody always says I vote yes, but it's up to me. No, but good idea for trying to use probability against me. So. All right, couple things. Probability of an event. So probability that event A happens needs to satisfy this statement. It needs to live between 0 and 1. We already went over that. It's just a reminder, and it's a different way to read it. S, remember, is your sample space. The probability that S happens is 1. Our sample space has to occur for us to find any probabilities. So probability rule number 1 is the complement rule. The complement of any event A is the event that A does not occur. Written as A superscript capital C. Yeah, subscripts are down below, superscripts are up top. It's not A to the power of C. That's not how we read it. It's a superscript.
Why?
I don't know. I didn't come up with that, just like I didn't come up with curvy braces. Who would name those curvy braces? Like, if you could come up with any name, like, come up with a cool name. So the complement rule. Probability of a complement. Did you hear how I read that? A complement.
So you complement it with like signals?
What does complement mean in geometry?
Oh, Jude, you expect me to remember geometry?
I do expect you to remember geometry.
How many years ago do you
We
think
have
I took
complementary angles and supplementary angles. Complementary,
They add,
no,
subtract,
those were
greater.
congruent.
divide.
Add to 90 degrees.
90 degrees.
So complements, A and A complement, need to add to 1. Because if A is happening and A is not happening, the total probability should be 1. So the probability of A complement can be found by taking 1 minus the probability of A. So, if we go back up here to this example, if we want to find the probability that we roll a die twice and the sum does not equal 7, we could find that by taking 1 minus the probability the sum does equal 7, which we found up here. Now, up here we used A instead of the word sum of 7. So the probability the sum does not equal 7 would be A complement.
Wait, what is that line? What is the line between? Yeah, what is
Not equal.
that? Okay.
And if we know that the probability of A getting a sum of 7 is 0.166, we can find the probability that we don't get a sum of 7 by subtracting 1, which is going to give us 0.8333 repeating forever and ever. Now, because this is something that is a little more tangible for us, we know that there are 36 outcomes total for rolling a die twice. 6 of them got us a sum of 7. So how many would not get us a sum of 7? 30. Hey, you just used the complement rule because you subtracted 36 minus 6. So sum that it's not equal to 7. There are 30 out of 36 ways that we would get that. And if we do 30 divided by 36, you get 0.8333, like the complement rule got us. Now we're gonna fill in the first rule on our rules of probability. And like I said, even though it's rule number 1, it's the simplest rule, so we're gonna put it at the bottom in the small space. Everybody okay if I cover this page?
Yeah.
1 second.
1.
That's what I was gonna do, Maggie.
We're just on the same page.
We are. Thank you. All right, so the column on the left is the name of the rule, then your formula, then an example, notes about when to use it. So first one is the complement rule. So the probability of A complement comes from 1 minus the probability of A.
And you said that this one was the easiest?
This one is the easiest. Now, the example I'm going to put in pencil, and you might want to also, because we will have more examples of this rule later. But for now, the example we did was the probability that the sum does not equal 7. And we found that by doing 1 minus the probability the sum does equal 7. So we did 1 minus 0.166 repeating to get the 0.833 forever. But you may want to change the example. So if you put it in pencil, that way you can choose. Notes about when to use keywords, I would say, might be a good thing. You're looking at the event something doesn't happen. So you would pay attention for those words. Any other notes you might want to make to yourself about when to use it? And like I said, yes, I see you guys tomorrow. Tomorrow we're going to look at ways to compare theoretical and experimental probabilities using simulations. And we're not going to learn a new rule tomorrow. But then every day after that, we learn a new rule of probability. Tomorrow we're going to learn a strategy for doing probability. Tomorrow is a C day. Try your exit task. It's 2 simple little problems. Also, notice I put this on the unit overview also, but 45, do not do C. I liked A and B. C covered something I haven't talked about yet, so skip C on 45.